Chris Lehto, retired F-16 pilot turned UAP investigator. Very excited to bring this video to you today. Sorry I missed last week, but hopefully we'll be back on schedule. This is a Flir1 re-attack, so from the famous Nimitz engagement, our only video evidence. So 14 November 2004, Commander David Fravor, now famous, who intercepted the Tic-Tac as it was over the water. He saw some disturbance. He was vectored there by Kevin Day, who was on the Princeton, Aegis class cruiser with powerful radar, directed David Fravor onto that location. He saw the Tic-Tac along with his Wizzo and wingman Alex Dietrich, who was piloting that. Lieutenant Commander Slate was in the back of her jet. Tic-Tac comes up to meet David Fravor and then jets out of there, disappears, accelerates, however you want to describe it, like a bullet, Commander Slate said. So they bingo their gas, they run out of fuel, they come back to the carrier, and on the way, Kevin Day, I believe he tells Fravor, hey, that thing is back at your cap point. So basically where you guys were gonna go, that thing is sitting there now. They didn't see it go there, but that's where it was located. They at least saw contact there, which is very strange. Comes back to land, and so Fravor tells Chad Nuts Underwood, hey, go out there and video this thing. And that is the famous Flir1 video that we see. It's Chad Underwood getting vectored to what looks like the cap point, and he tries to get it on as many video modes as he can. He doesn't change polarities. I don't know why. They just don't use that maybe in other services. In the Air Force, we always change polarities. But the information is technically there. It's just instead of a white dot, it's a black dot. So it's just the way it's presented to the pilot, but you can break out some better information. I learned some really interesting stuff here because when I first looked at it, I was in this debate with Mick West. Now that the dust has settled, I went back and looked at the video in much more depth, and I found some interesting things. I think you will see something you haven't seen before, hopefully. Hit that like button. If you like this content, please subscribe to get notifications in the future. And if you want to support the channel, go to patreon.com/Chris Lehto. Thanks for being here though with an open mind. On to the video. First thing, we'll just watch through the whole video real time. I'll give you some points, but basically I have divided out into 3 phases. I have the first orb phase, the second TV phase, and then the third phase with the Tic-Tac. What I did is I drew it out every 10-second intervals. The fighter is carrying this pod on the outside of the jet. They're going 0.55 Mach. So that means they're going 5.5 miles per minute. So we can approximate that. They go around a mile every 10 seconds. So what we do is old school fighter pilot techniques. You put a little line here. I don't know which way he's going, but I assume they're actually heading east. Okay, I'll tell you why I think that in a little bit. But we start T0, and then I drew an angle 4 degrees off. Okay, the pod gives us an amazing angle relationship to a target. It doesn't tell us range. It doesn't know range. Okay, it has to get it from somewhere. It does have a laser it shoots out, but we don't see the laser shoot. And actually the whole time we never get any range. As you'll see, it's denied. The radar is not getting ranging, and we can't tell. So we can estimate though, but it gives us great angle. And it tells us it's 4 degrees to the right of bore sight on the aircraft and 6 degrees low. So 6 degrees low is not so much. He basically stays there. It does go to 5 degrees a little bit. So maybe they're closing, we're not sure, but just 6 degrees low, 4 degrees right. Really, I'm gonna watch this one, okay? And I plotted it. So this is from overhead. T0 is the fighter. They just go straight the whole time. Every 10 seconds they go a mile. So I measured out 1 nautical mile is 1 centimeter. As you see here, my centimeter stick. So T0, T0, and it basically just kind of stays at that angle, okay? Almost like they're following. I would assume they're following. So this is the basic engagement, and we can go through in more detail later, but the fighters stay straight ahead every 10 seconds. And then what we see here is we're not gonna see any real line of sight, and then you're gonna see more rapid line of sight until the break lock is over here. 1 centimeter equals 1 nautical mile. So let's just watch it through straight. I'll talk through. We're in infrared. Okay, and I see a ball here. I just see one large circular ball, which does seem strange. He's going to zoom in now. We're looking, we went 4 to 3, it went back to 4. So back to 4 degrees here. So it's just same angle. Now he zooms in, so zoom 2.0. We go to TV mode now. You'll notice it's a little more zoomed in. TV mode's a little narrower field of view. And here what I notice is it gets longer, okay? It goes from 6.5, what I measured, 6.5 centimeters to 8 centimeters on my measurement. But he doesn't really get taller. So what that suggests to me is that he's turning. that we're seeing more of some translational line of sight. And then this is the third phase here. Okay, that's like gimbal that Mick West want to talk about. Looks like maybe it does gimbal, but I don't see the actual object rotate. There was a little gimbal again. Wings are straight and level, like I said. 5 degrees now, 6 degrees, so he's kind of zooming off to the side here. Now the zoom in, look at that. Woo! And now it goes back out, back in, and loses the lock. Okay, Chad Underwood says because it flies off. That's what he said. It actually flew off. I couldn't prove without a shadow of a doubt just from the video that it didn't break lock. It's definitely accelerating to the left, as you see here over in this how I mapped it out. Okay, so if you want to see that again, here's 0 time, right? T0, T0. We go forward 10 seconds. There's 10 seconds, right? And he's still 4 degrees off. So T0, 10 seconds. The fighter went 1 nautical mile in that time. This thing I approximated, it went about the same. It looks like it's going concurrent. Normally, if something's going the same speed as you, it's going to be, as you move, it's going to be moving away, right? So it's going to stay the same size. But if you move towards it and it stays in the same location, it's going to get bigger. So you're going to have actually a larger, should be getting larger. What I see actually when I looked at this is it actually gets smaller. We can zoom in here. So now I'm going to zoom in. 400%, just zoomed in Premiere Pro. Smaller as I go forward, forward, forward. See, it's actually gotten smaller. I think it's focusing. So if you watch the tracking gates, as I do it again, you watch the tracking gates, they're moving around and they're actually tracked. Right? If you go through the middle of them, I mean, the pod thinks it's tracking a ball, a sphere-shaped object, right? Maybe that's from the back. Could be what we're seeing is the rear part of a cylinder possibility with some reflection. But what looks weird is as we zoom in, the actual pod zooms in, okay? What we're seeing is, it looks like, yeah, a ball here is what I see. And we're missing some parts here. It could be reflected on top, or it's just a crazy image. But I thought it was interesting that it looks like the shape of a ball. And the information stays there, right? As I actually ink deck through, so click through the frames, that's each frame. So that's what information is coming in. I thought it was more like a reflection. So that is at 20 seconds. He's right here, 20 seconds. There still hasn't been any real change in line of sight, right? So that gives me the impression it's going the same speed as the fighters. And now we're going to start to see some change in line of sight to the left. See, so he zooms in. You saw it was in 1. Okay, this is TV, narrow, 1 zoom. And now he's going to zoom, double the zoom. Boom. So it doubles the zoom. And now we go to 30 seconds. So 30 seconds, what I notice is it gets longer this way, but not necessarily taller. So T30 here, the fighter is here, and this guy is here. So just 2 degrees to the right. Play forward another 10 seconds. Basically like flying here. Let me stop. Okay, now it almost, then I was like, maybe it does look like there's a tail or a wing or something, but it doesn't stay. And it's more like just blurred. That's 40 seconds, so right off the nose. So basically right off the nose now. See 0. So it looks like it may be angling away. What we're seeing is a slight angle away. I didn't draw it necessarily here, but it's angled that way. That was 50 seconds. So 50 seconds is back in IR mode. Okay, so what I noticed on TV mode I already mentioned is that I'm expecting to see more increase in size on the screen if it was getting closer. So I think what we're seeing is it's getting actually longer, right? So I think we're seeing a turn, slight turn, or a change in aspect. Our aspect is getting higher. That was the gimbal. What I noted is it doesn't change, doesn't spin the actual impression. We'll zoom in here. So here, even here I can see, I stopped it. They're basically at 1 minute. It's on the left side here. It looks like an object with a shadow. So there, to me, it looks like a tic-tac. Like you can see, it's clearly the shape is outlined here. And I see there's like this is from a reflected light, I believe, from the sun. I'll zoom in here in a second. It's 110, right? So big over here, almost the brake lock. Boom, and then zooms in. So here, this just looks just like a tic-tac to me. I mean, it's very clear. You know, these are frames. As I'm framing through, you'll see it maintains that same shape. These are many frames, okay? And then it goes back. And again, you can still kind of see it. I didn't do any sharpening or anything to this video. I just put it into Premiere Pro. But you can just go, I can frame, as I frame backwards, the information is still there, right? I mean, these are like shadows kind of changing, right? So basically, I see kind of a line, a shadow here, and then there's definitely a structure. I don't see anything below it. You know, I've seen before, there's like little things hanging down. But I'm going backwards here. I don't see anything hanging down, but I also don't see anything else. It's just a smooth, like, it's like a sports car that just has a clear surface. Okay, so now I'm running it back straight. That's the very end. You'll see it loses lock, breaks lock, and then disappears. Right at 180. So basically it breaks lock right here. So interesting points there, I thought, was the engagement, how it went. It was interesting that it was traveling the same direction. So it did change direction, I believe, during the video. Or at least our relationship changed, because it didn't appear to be getting closer or would have gotten larger. So I think it was going the same direction as the fighter, and then it turned and probably went more like this, off to the left. And I believe based on the sun, so this is the sun calc for that day. So if you go to 14 November 2004 sun calc, you can get where the sun is. And basically it's going to be coming from the south. For that general location, okay, for 14 November 2004, this happened southwest of San Diego. And sunrise was at 6:19, sunset is at 16:53. So culmination is close to noon, 11:36. Out of the south, so 71 degrees. 71 degrees is the altitude, max altitude. So it's going to be high, but out of the south. Same with the moon on that day. So the moon is also down there. Basically, it's going to be cycling through, culminating. It sets at 1847. Moon culmination is at 150. So the sun and the moon are up there, given reflective energy, and that's showing up what I see in the Flir1. I mean, that is a great picture right there. Look at that thing just clear around, shining. Yeah, crazy stuff. And then if you go back to the beginning now, if we look back at this, it tends to make maybe a little bit more sense, like we're having a reflection from the sunlight is aiming this way, and you're getting kind of weird reflections off the top of a surface. But why aren't we seeing the rest of it? You know, why aren't we seeing the other side of it, the bottom? Or is this the back end of the Tic-Tac? What's weird is I did when I sized it. Even cooler is I got a size estimate for both of these, the orb and the Tic-Tac at the end. If we use a 1 degree field of view for the Flir targeting pod from the SCU report, then we know this is 17.4 milliradians across, right? 1 degree equals 17.4 milliradians. And so with some math now, you can measure, I measured on my screen, measured this at 18.5 centimeters, 185 millimeters. So I know that is now 17.4 milliradians. And so when we measure this, we can measure this at 6 millimeters is what I measured it at. We do some cross multiplication math, and we get that X is equal to 0.564 milliradians. That's how far this is across, right? This is 17.4 milliradians. This is 0.564. So why do I do all this work to convert into milliradians? because now if it's at 60,000 feet away, which is 10 nautical miles, we can multiply 0.564 times 60, and we get a length of this thing of 33.84 feet across. That's if it's at 10 nautical miles. 15 nautical miles away, it's 50 feet, a little shorter than a Hornet, but it's quite a bit taller. So it could look bigger in person because if it's shaped actually like a cylinder, which it looks like it is here, it's quite a bit taller. So it would be, in that case, it would be 50 feet long, and it'd be a full like 12 or 15 feet tall. That's thick. So anyway, that is the size. And if the range hasn't changed, and we go back to this thing now, you can do effectively the same thing, and I measured out the same thing. So that would mean that this measured across would be the same relationship. I measured this at 6 millimeters as well, because it'll be at zoom 1. So I measured this at 6 millimeters. So it's close to about the same size as the Tic-Tac. Actual shape, if you look at it. Like maybe it is oriented kind of funny, so maybe it's in a funny orientation, oriented like this or something. But anyway, this looks like about the same size, 50 feet across if it's at 15 nautical miles from here to here. If it's a complete circle is what I kind of treat it as, like that. What do you guys think? Please write in the comments what's your take on this video. What would you like to see?